All right. Hi, everyone. Mukil from LangChain here. I lead our infrastructure team and super excited to talk about running untrusted agent code with LangSmith Sandboxes. Usually, they don't let the infrastructure team outside the basement, so I'm super excited to be here today. I think if you look across the last 6 months, one thing that we're kind of seeing as a transitionary point across the industry is that agents are writing real code today. I guess quick show of hands, who here uses Cloud Code, Deep Agent CLI, Devin, et cetera? Yeah, I think pretty packed house. I would guess maybe 70% of the people in here raised their hand kind of on using coding agents. Sundar Pichai recently said 75% of code at Google is being generated by AI. GitHub released a lot of statistics kind of on how many PRs and code percentages that they're seeing. 41% of kind of commits this year seem to be coming from AI as well. Stripe published a blog where 1,300 PRs per week are just generated by their internal minions coding agent. So we're kind of seeing coding agents as this meta shift that's here to stay. The first kind of main use case that we've seen this is in the field of software engineering, which is probably what brings most of you here. OpenSUI is our internal kind of open source coding agent that we use as well. It's connected to our Slack, GitHub, et cetera, and it commits hundreds of PRs across our variety of repos. Cloud Code needs no introduction. Basically, it's taking Anthropic to the moon. Devin doing tons of cool stuff with sandboxing as well, with local kind of coding and being able to hand it off to the cloud. And Ramp's written a lot of blogs about their insights agent and how they have built this validation loop where you can take screenshots and things to kind of code completely autonomously and keep humans just doing the management part. But actually, we're seeing this expand to tons of other use cases as well. It turns out that giving an agent access to a computer is actually super powerful. Data analysis is a super big kind of emerging trend as well. Instead of providing predefined SQL tools and things like that, you might just give your agent the ability to write scripts and load data as a CSV, and it can kind of figure out how to generate a graph or do analysis as well. So we're seeing this in the financial space with companies like Julius. We see it in kind of data analysis products like Hex. So very, very popular trend as well that we're seeing as an extension of these coding agents. Security, another super cool one. Companies like Expo, Corridor, et cetera, will run automated pen tests against your infrastructure. So tell an agent to try and figure out what's wrong. And they'll kind of autonomously run and perform really powerful penetration testing that typically would be super labor intensive. And this is kind of an extension of the ability to use execute code is this idea of browser and computer use, right? So not only are we allowing the agent to write code, we're allowing it to actually control a browser or control your entire system. Some examples of this would be Stagehand, which does automated playwright testing. You can have it kind of non-deterministically go through your UI and verify bugs. Claude Cowork can control your whole system and do cool things there as well. But as the saying, as Uncle Ben once said in Spider-Man, with great power comes great responsibility. It's actually super risky to basically just allow this untrusted thing to execute code randomly. These are all from this year. So earlier this year, we had the Shai-Hulud attack, actually, I guess earlier this last month. And that would basically, if you install the package, just export all credentials that were on your machine. A human, we don't even really trust humans to deal with this. I don't necessarily trust an agent to do that either. Top tech startups are even running into issues like this, where N8N recently had a sandbox escape vulnerability where you could use certain JavaScript tricks to escape the sandbox that they provided. And prompt injection is a concern for anyone building agentic apps. Recently, Google's anti-gravity browser had an issue where you could kind of inject the prompt to actually escape their sandboxed environment. And that's where this idea of a sandbox kind of comes in. It's this separate infrastructure primitive that allows you to execute code safely and remove it from your core runtime. There's a couple key characteristics of this. There's also different levels of sandboxing, where you might be sandboxing just code execution, you might be sandboxing an entire computer, et cetera. But that's what the core primitive is. And that's also where kind of LangSmith Sandboxes comes in. Because building this primitive is actually quite hard for a number of reasons that I'll walk into. The first problem is that agents are becoming user-facing. So users expect fast responses. I get pretty mad if I'm waiting a few seconds for a response. I think we've gotten a little OK with it with LLM apps because LLMs take a while to respond, but you still want some near-time latencies. And agent-facing workloads are also, user-facing workloads are also fairly dynamic. They can scale up to thousands. You might have bursty workloads, things like that. So with LangSmith Sandboxes, we solve this with the ability to scale. So we're actually a little bit faster than this. We kind of constantly benchmark this and are constantly working to speed up our sandbox spin-up time. But we have a P50 of like 0.98 seconds right now, so a little out of date here. You can also spin up thousands of sandboxes dynamically. So you don't need to maintain the compute to run thousands of these things. We'll kind of do that for you and make sure that's like orchestrated and cached well. I guess the other problem is that with users, you also get bad actors, people who are trying to leverage your compute and do bad things with it. Container escapes are a huge problem that we've seen and kind of show that containers are not enough for this kind of product. Just recently, there was the copy fail attack where you could have a 700-byte script, and you could kind of get access to the full host kernel and do malicious things to your environment. Prompt injections, I already mentioned. A poisoned README or something can get your agent to just export the environment to a random website and things like that. Malicious MCP servers are also kind of just another area that we're seeing as kind of like a honeypot to get your agents to do bad things. And so on the LangSmith Sandbox side, we have this concept of an Auth proxy. Basically, all network goes through the sandbox. And so you can lock down the environment, kind of how you would a computer in an enterprise. You can basically set allow lists, deny lists, keep the credentials as part of the proxy so that actually there's nothing sensitive in the runtime itself. And this is super powerful. You can block these MCPs. Even if you get prompt injected, you can survive. And we're really excited about this as kind of a core primitive as part of our sandboxes. The third problem is that agents are kind of long-running and interruptible. And we're only seeing these get longer and longer running. Sandboxes need to be able to start randomly, pause, resume. And you also don't want to lose that state. Like if I turn off my local computer and I turn it back on, I have all my files still there. The agent kind of expects that same kind of thing as well. And that's super powerful. Traditional workloads kind of don't really support that. So with LangSmith Sandboxes, we've enabled this with a pretty durable persistence layer. So any state that you build up on your machine, you can keep. You can also throw it away if you want. We support the ability to pause and resume. So because we have super fast spin up, you can spin it down in times of inactivity and spin it back up to only pay for kind of compute that you're actually using. We also have no limits on how long you can keep a sandbox alive. Most of the other providers have kind of a limit for you can keep it up for 4 hours or something like that. We have no limits because we know that maybe you want your agent to just be kind of running in the background for hours or even days. And then we also have the ability to have multiple agents interacting with the sandbox. So if you have kind of shared state that you want multiple agents to work on, also like your local computer, you can kind of do that as well. And kind of the last problem that we're seeing is that agents make mistakes. Most of you are probably doing evals to try and prevent a lot of this, but agents can always make mistakes. And this is just a problem that's inherent of the stochasticity of these things. So on the sandbox side, we support a bunch of capabilities that help with this. At any given time, you can snapshot. And what that really empowers is the ability to also restore. So I recently had an agent delete my /etc/resolve, broke all DNS. I wish I could have checkpointed and restored, but unfortunately I didn't have that. But you can do this in our cloud. You can also fork. So take that initial state and maybe try out 10 different things as well, if you want to kind of continue from that point. You can get started with one line of code today. It's part of our LangSmith SDKs, so feel free to get started. It's available on all paid plans, as I mentioned. You can bring your own file system. So if you already have Docker images that you might be building, et cetera, with packages that you want installed, or a CLI, whatever, that works kind of out of the box. And it plugs into your stack. This wouldn't be LangChain if we didn't have a rich kind of open source ecosystem around our products. You can use this in deep agents, OpenSUI. We have a CLI. Tons of kind of features across the board in our open source as well. We have a lot on our roadmap. We're very early in kind of the life cycle of this product. I was mentioning local remote handoff that I'm super excited about. Shared volumes is another one. So bring the same code or files to a bunch of different agents at the same time. And then we're an observability company. We do also want to support full execution tracing, so see what's actually happening on your sandbox as well. Try it on LangSmith today. It's available on all paid plans, released in all our SDKs, and would love to hear your feedback. Thank you. My name is Mukil. Yep. Yep. I do have to say, it takes a village. Like our whole team has been sprinting on this, so very thankful for them. I'll be around all day, so if you're excited about this, please come chat.